Hi everyone, this is Mrs. Musoff, and we are going to keep talking about logs today, but we're going to move into something different, the properties of logarithms, which is really just the rules that go along with expressing a logarithm. Alright, now remember what we talked about when we first started talking about logarithms. A logarithm is just an exponent, and so because of that, the exponent rules that we know so well are really the same as the logarithm rules. They just look a little different. Alright, so let's remind ourselves about what those exponent rules are. There is a product rule, which says that if I have two powers, x to the a times x to the b, product, because it's times, that means I can add my coefficients. So multiplying powers turns into adding coefficients, or not coefficients, exponents. Multiplying powers turns into adding exponents. And quotient, same idea, except instead of multiplying, it's dividing x to the a divided by x to the b. And that turns into subtracting your exponents. And the last one is the power rule, which says that if I have x to the a raised to the b, so if I have more than one exponent, I multiply exponents. Alright, so these three rules are going to show up in logarithms too, and maybe they'll look a little familiar from last year. Maybe not, no big deal either way, because we're going to review them all brand new. Alright, the main thing to pay attention to with these first two rules is that multiplication goes with addition, and division goes with subtraction. Alright, so for example, our log rules, we have a product, a quotient, and a power rule as well. The product rule says that if I have the log base b of x plus log base b of y, I can rewrite it as one logarithm, but that addition turns into multiplying. Right, so adding exponents, because remember a logarithm is just an exponent, so adding exponents is equal to the logarithm of just multiplying what's inside. Alright, and same kind of thing with the quotient rule, except quotient division, that goes with subtraction. So log base b of these expressions, when I subtract them, I can rewrite it as just one log with division. Alright, the last rule is a little trickier to see the connection, but there is a connection there. The idea is if I have two exponents, I can just multiply them. Well, same thing with the power rule, except you have to keep in mind that a logarithm is an exponent. So if I have a logarithm, log base b of x, to the y. So again, keeping in mind like this is one exponent, and this is another. Alright, so if I have an exponent to another exponent, that means that you can just multiply the two exponents. So what we do is this exponent we bring to the front, and it turns into kind of a coefficient. Alright, exponent times exponent. Alright, so let's see if we can use these properties to actually simplify some logs. So take a look at example 1. Evaluating without a calculator, so no calculator at all. The first one says log base 6 of 4 plus log base 6 of 9. So the idea here is, because this is a base 6 and this is a base 4, I can't find a way to kind of rewrite it like we did before, right? This is kind of like saying what exponent turns 6 into 4, right? 6 to the what would equal 4? And that's a question I can't answer, because 6 and 4 don't have that kind of relationship where I can just know what that exponent is. So because of that, I have to think of a way to use my properties. And if you look at the product property, it says that if you have two logarithms that you're adding, you can rewrite it as one logarithm and multiplication. So that's what I'll do here. Alright, log base 6 of, and then I'll just take what's inside, and I'll multiply them. So log base 6 of 4 times 9. And on the surface it looks like, well, that didn't really help me much. But if I simplify, log base 6 of 36, now maybe you can see why it would help. Because now I should know what exponent turns 6 into 36, because that's just 2. Alright, so using these properties can help us to evaluate these logarithm expressions without having to do some complicated thing on our calculator. Alright, same kind of thing with letter B. So log base 2 of 2 to the 13th. Alright, this is going to be that power rule. Power rule says that if I have an extra exponent here, I can turn it into a coefficient. And that's what I'll do here. So that 13 will bring to the front. So it's 13 times log base 2 of 2. And then hopefully this looks familiar. When your bases match, right, that's like saying what exponent turns 2 into 2? Well, that's just 1. So we get 13 times 1, which is just 13. Alright, one more basic one, just making sure we really got these properties down. So letter C, it says log base 8 of 16 minus log base 8 of 2. So again, kind of hard to rewrite as an exponential because I wouldn't be able to solve it, right? It looks like maybe I would, 8 and 16. But when I say 8 to the what is 16, I don't have an answer for that because even though 8 and 16 seem like they're related, they're not exponentially related, right? I can't like put an exponent with one of them and get the other. So I still can't do it that way, so I have to use my properties. Alright, subtraction turns into division. So I can rewrite it as log base 8 of 16 divided by 2. And then again, if I simplify that, log base 8 of 8, I should be able to answer the question. Alright, what exponent turns 8 into 8? That's just a 1. Alright, so that's kind of the idea. Use these properties to help us simplify. So go ahead and flip it over. We're going to try a different type of problem, but same overall process using our properties. So in example 2, it says, given log of 3 equals a, and log of 5 equals b, write the following in terms of a and b. So basically we want our final answer to just have a's and b's. Alright, no more logs, no more numbers. But in order for that to work, we really have to recognize that a is log 3. Not 3, but log 3. Alright, and same thing for b. b is log 5. So really the goal of these problems is going to be to rewrite the logarithms as separate logs, right? One that's a log 3, one that's a log 5, so we can replace it. So basically here we have to expand first using our properties. Right? What I mean by that is, for example, letter A, it says log of 15. Well, 15 is not one of the numbers they gave me. But if I rewrite 15 as log of 3 times 5, which is still 15, but what I can do is then I can use my property to expand this out, right? As is, I can't replace anything because I don't have a log of 3 times 5. But my property says that when I'm multiplying inside of a log, I can rewrite it as addition. Right, so log of 3 times 5 can turn into log 3 plus log 5. And now I should be able to replace it because I know log 3 is just going to equal a. And I know log 5 is just going to equal b. So I end up with my expression just in terms of a and b. That's a plus b. Alright, so that's kind of the idea with these strangely worded types of problems. We just want to expand them into separate logs so that we can replace them. Alright, same thing in letter B. Log of 5 divided by 3. This one at least we don't have to rewrite. It's already in terms of 5 and 3. So I just have to expand it out. Division turns into subtraction. So this is log of 5 minus log of 3. And again, now they're written as log 3, log 5. I should be able to replace them. So log 5, that's b, minus log 3, that's a. And there's my answer. Alright, sometimes you'll get ones where it's not both of them. Maybe you can just rewrite it as just one of them, like log of 25. There's no 3 that I can create in 25, but 25 is 5 squared. And I have a rule about exponents. I can bring them to the front, turn them into coefficients. Alright, so now this says 2 times log 5, and I happen to know that log 5 is b, so this is just 2 times b. Alright, so that's the idea there. Alright, now let's try just a couple examples, where we actually are just expanding these out. And the whole point of expansion is to maybe create individual logs that can simplify a little easier. Right, that's why we expand. So that's what we're always looking for. After we expand, can I simplify anything? Because that's the goal. So example 3, expand. That means taking your logarithm and writing it as multiple logs. So for example, in letter A, it's log base 3 of x divided by 9. So I have 2 different pieces here. I have an x and I have a 9. So expanding means giving both of those a log. So it'll turn into log base 3 of x. Division means subtraction, so minus log base 3 of 9. And then again, the goal here is by doing that, did I create a logarithm that I can now simplify? Well, log base 3 of x, no, because it's x. But log base 3 of 9, I should be able to simplify. Alright, because log base 3 of 9 says what exponent turns 3 into 9? And that's 2, right? 3 squared is 9. So I can simplify little bits and pieces. So there's my expanded answer. Alright, now you can't always simplify stuff, but that's just kind of the goal, right? That's why we expand. So same thing in letter B, log base 7 of x to the 5th. I only have one term here, x to the 5th, but that exponent can turn into a coefficient. So I have 5 times log base 7 of x. And then I'll ask myself, can I simplify log base 7 of x? No, it's got an x in it. So that would be my final answer. Alright, last set of examples. That was expanding. That's where we take one logarithm, stretch it out and do a bunch. Example 4, this is condensing. So now we're trying to take separate logarithms and condense them into one single log. This is going to be really important when it comes to solving. It will help us solve. Helps us solve. So it's really important that we're able to do it now so that later when we solve, that part of the problem is a piece of cake. Alright, so basically what we did with expanding, we're going to do the opposite with condensing. And what that means is if I have exponents, if I have coefficients, I'm going to turn them back into exponents, put it back inside the log. And if I have subtraction or addition, I'm going to turn them back into division and multiplication. So here, for example, 2 times log base 3 of u minus log base 3 of v. So the first thing I do is I see a coefficient, and so I'm going to turn that into an exponent. So that'll be log base 3 of u squared. Right, the other one doesn't have it, so I can just rewrite it. After you change those coefficients to exponents, now it's time to condense them together. When it comes to condensing, your answer should only have one log. Only one log. So I see a lot of people accidentally changing subtraction to division, for example, but keeping separate logs. That shouldn't happen. My final answer should only have one log base 3, so I'll always write it like this. And then whatever I'm condensing is going to go in the parentheses, no logs. So u squared, and subtraction turns into division, so divided by v. So there's my condensed log. Alright, same kind of thing with letter B there. Again, if I see coefficients, change them to exponents. So these is natural log, in case you forgot, natural log of x to the 5th plus natural log of y to the 3rd. And then again, our answer when we're condensing should be one natural log with stuff inside. So I always write it like this, natural log with parentheses. And then the parts that are inside go inside the parentheses. And the way you can tell how is with the sign. So this one, for example, we have x to the 5th and y to the 3rd. And because it's addition, I'm going to multiply. So x to the 5th times y to the 3rd. And then if I could simplify it, that would be great, because that's kind of why we condense, just like that's why we expand. Unfortunately, in this one I can't, so there would be my answer. Alright, so we're going to practice this a bunch more when I come back, but hopefully this gives you an idea and you can try some of those homework problems and see how they work out. Make sure you check your answers, and if you have any questions that you can think of, just write them down so that I can answer them for you in class. Alright, thanks for watching and listening. I will see you later.